Hi, I'm Mr. Kangas, and today we are going to take a look at Chapter 10, Section 6, Area Formulas. And specifically today we're going to be talking about the area formula of a rectangle, which won't take long. I know this is not one of the shapes discussed in Chapter 10.6, but this shape and its area formula is actually kind of the foundational piece, or it's something we're going to be referencing a lot. All the other area formulas that exist stem from the rectangular area formula. If we did not have an area formula for a rectangle or a square, then the area formula for triangle, trapezoid, and parallelogram would not exist. So all area does is it takes a shape and it splits it into 1 by 1 squares. You're asking yourself, how many 1 by 1 squares fit inside this shape? And the unit of measurement changes depending on what it is you're finding the area of. Sometimes you may be finding how many 1 by 1 inch squares fit inside. Sometimes you may be finding how many 1 by 1 mile squares or 1 by 1 centimeter squares fit inside something. So first thing we're going to talk about today, we're going to split it into inches, pretend inches, because I'm not actually going to take a ruler and measure it out, but we're going to split these things into inches. And we're going to find how many 1 by 1 inch squares fit inside a rectangle. Now, most of us have heard of the rectangle formula, length times width. I will tell you that from this point forward, you will probably more commonly be referring to it as base times height. And you're going to want to learn this and remember this. Area formula for a rectangle is base times height. Okay, and then the area formulas for triangle and trapezoid and parallelograms will make much more sense to you because they use the base and height reference. So 3 is my height, 4 is my base. So what the area formula's goal to do, as I said before, it's to split this shape into as many 1 by 1 squares as is possible. In this case, we're looking at 1 inch by 1 inch squares. So if if the height of the rectangle is 3 inches, then that means we have 3 pieces that are 1 inch each. So we have 3 rows, in other words, that are 1 inch high. We have 4 columns that are 1 inch wide. And so we have 3 sets of 4 columns, or we have 4 sets of 3 rows. In total, we have 12, or 3 times 4, 1 inch by 1 inch squares. The reason why we multiply the width and the height is because multiplication is repeated addition. 3 times 4 literally means either you're going to add 3 4 times. So in other words, I've got these 3 block columns, and there are 4 of them, so I'm adding 3 plus 3 plus 3 plus 3. Or the other thing that multiplying 3 times 4 means is you're adding 4 3 times. So that would be, I have this row with 4 squares in it, and you're adding 1, 2, 3, 3 rows of 4. So I'm doing 4 plus 4 plus 4. And that's how you get how many 1 inch by 1 inch squares fit inside this rectangle. So the answer to this, the area would be 12 inches squared. Anytime you see a unit of measurement such as inches, centimeters, kilometers, miles, whatever, with a power of 2, that means you're talking about area. So if someone throws out a number at you that has one of these little powers of 2 on the unit of measurement, then you know they're talking about the area of something. So that's all there is to area of a square or rectangle. Again, it's just base times height. Many of you have learned it as length times width. We're going to be talking about it as base times height, and this is why it works. This is going to be very important to understand this in order to move forward and understand why the other formulas work. So the next video will be on parallelograms.